Hello, in this session, let us take up the discussion on this robotics. Yes, we'll discuss the basic introduction to the robotics and the types of joints in the robots and also the types of different, we can say it as classification of robots. Let us begin with the basic introduction for this robotics. Yes, an industrial robot is a general purpose programmable machine processing certain anthropomorphic characteristics. So it's a general purpose machine. It can be used for any of the general applications as well as it's a programmable one. This industrial robot can be a programmable one. Will program and will make the robot to perform certain tasks and possess certain anthropomorphic characteristics. That means it, it exhibits some of the human characteristics, or you can say it exhibits some animal characteristics. That is what this anthropomorphic characteristics. So it can perform certain tasks like human being. That is what I have been telling here. Next, the most obvious anthropomorphic characteristic of an industrial robot is its mechanical arm, which is used to perform various industrial tasks. Yes, most obvious human characteristics of this industrial robot is its mechanical arm that will be similar to that of human arm. With the help of that mechanical arm, this robot will be able to perform various industrial tasks. Simple task is picking and placing of element or picking and placing of a material. So starting from that simple task, it can perform even that many complex tasks which are not able to perform by human being. So with what this mechanical arm that is similar to that of human arm will make that permit the robot to perform certain industrial task. And other human like characteristics are the robot's capabilities to respond to sensory inputs, communicate with other machines and make decisions. And along with that mechanical arm, it has other properties like it can respond to the input commands as well as it can communicate with other machines and finally make that decision required. So thereby which that almost that robot can perform as human being only. It has a mechanical arm which is similar to the human arm, and it can respond to input commands as well as it can communicate with the other machines and also it can make decisions. So these characteristics make that robot as a most important thing or most important one for industrial application. Yes, these capabilities permit that robot to perform variety of useful tasks. As these capabilities make the robot to perform variety of industrial useful tasks. So this development of robot technology followed the development of numerical control, and these two technologies are quite similar to one another. We have some numerical control machines where the machines need not to be operated manually. We will give that coding, we'll do the coding and all, and we'll give that coding as input to those machines, and those machines will read the coding and then they will do that all the required operations. So that is what numerical control technology. And even this robot technology also here will, as we said, it's a programmable one. We will program and we will feed that as input to that robot, and the robot will perform according to that. Yes, these two technologies are quite similar to one another. They both involve coordinate control of multiple axes. The axes are called joint in case of robots. That is, controlling of giant has to be done in case of robots, and both use dedicated digital computers as controllers. Yes, here for we will make use of that computers for coding, for giving input and all, in both the cases, in robot technology as well as numerical control technology. The robots are designed for a wide variety of tasks. Yes, these robots will be designed and will be generated for wide variety of useful tasks. Typical production application of industrial robots include spot welding, material transfer, machine loading, spray painting and assembly. Yes, production application of this industrial robots means this industrial robots can be made use in some of the production applications in industries. So to produce some of the complex parts or to work in some hazardous conditions, like with some of the applications they have mentioned here. Spot welding, that is welding, you already know that is joining of two materials here. In spot welding can be done by this industrial robot. Material transfer, picking and placing of that material transfer, a huge material picking and placing of used material can be done by this industrial robot. Machine loading that machines to that place wherever it is required, and also spray painting and assembly of different parts. All these applications can be done by that industrial robot. And next we have some of the qualities that makes the industrial robot commercial and technologically important are listed here. We have already we discussed certain properties, certain characteristics exhibited by that robots, and those are similar to that of human characteristics. Again, it has some qualities that makes that industrial robots commercially and technologically important, and we'll see one by one. Robots can be substituted for humans in hazardous or uncomfortable work environments. Yes, main application of this robot is robots can be substituted. Robots can be human beings in that hazardous condition can be replaced with the help of these robots. That's why they are telling that robots can be substituted for human in hazardous or uncomfortable work environment. Next, a robot performs its work cycle with a consistency and repeatability that cannot be attained by humans. Yes, you all know that even humans after one or two cycle or even after 10 work cycle, they may get tired and consistency will not be there. Again, repeatability will not be there. So for that, whereas this robot can perform its work cycle with a consistency and repeatability, whereas that cannot be done by human. And robots can be programmed. When a production runs of the current task is completed, a robot can be reprogrammed and equipped with the necessary tooling to perform different tasks. Yes, here, as we said, it's a programmable machine. One will program that robot and will assign that robot to perform certain task. Once that task is over, again, instead of making that robot to sit idle, we will reprogram it, and thereby which we will make that robot to perform a different task. And that is what they are telling it as, when the production run of the current task is completed, a robot can be reprogrammed and equipped with the necessary tooling to perform the different task. For example, once picking and placing of that material is over, and then we can assign that same robot for maybe spray painting, or you can with that necessary reprogramming as well as attaching that necessary tools to it. Or you can assign the same robot for spot welding by reprogramming that, as well as by by attaching that required tools to that robot. That is what they have been telling in this. Then robots are controlled by computers and can therefore be connected to computer systems to achieve that computer integrated manufacturing. Here, when the robot is used in that manufacturing or production process, and you all know that we need to make use of computers to control that robot, and when the computer is made use in the production process or in the manufacturing process, we will call that as computer integrated manufacturing. So if only that human beings are involved in that production process, need not to make use of computers. All the operations will be done by human beings, that is manually. So no computers are in there in that kind of manufacturing process. Whereas if you make use of robots, then definitely to control robots we need computers. So computer will be used in the production process. So we will call that type of manufacturing or that type of production process as computer integrated manufacturing process. So next, let us have some robot anatomy and related attributes. Actually, here they will tell regarding the joints and links, and also tell regarding the degrees of freedom. The manipulator of an industrial robot consists of series of joints and links. These are very important things. Joints and links are very important here. Robot anatomy is concerned with type and size of these joints and links and other aspects of the manipulator's physical construction. Yes, this robot anatomy is concerned with this type and size of these joints and links and other aspects of the manipulator's physical construction. Next, we have joints and links. Let us see what is this joints and link. Joint of an industrial robot is similar to joint in a human body. It provides relative motion between the two parts of the body. Yes, the joint of the robot will be similar to that of joint in the human body, and it provides relative motion between two parts. That is, like we can consider that, or you can look your wrist, which connects the two parts here. Similar to that, link in that robot will connect two parts. Joint in that robot will connect the two parts. One is input link and another one is output link. You just consider your arm or your hand from the shoulder part. Again, we have many joints here. One is this shoulder, one is this elbow, another one is this wrist here. Many these joints will come. These kind of joints are there even in case of robots. That is, the joints in this robot are similar to that of human body, that will connect the two parts. So in the two parts, in the sense, one will be that input link, another one will be the output link. Each joint or axis, as it is sometimes called, provides the robot so-called degree of freedom, or you can say it as DOF of motion, that is degree of freedom. But if you move that one link, definitely that you all know that these two links, that is input link and output links, are connected by joint. If you move one link, means that if you give input to that, or if you give some movement to that input link, definitely that output link will also move. That is, there will be a relative motion between these two links. That is actually called as degree of freedom. Next, we have this. In nearly all cases, only one degree of freedom is associated with each joint. That is, in almost all the cases, in case of this robot, one degree of freedom will be associated with each joint. That is, whether it can move linearly or it can rotate about that joint. The one degree of freedom will be given there. Robots are often classified according to total number of degrees of freedom they possess. So it will be robotic based on for robotic classification. Connected to each joint, two links, an input link and output link. That I think this is what I told in the previous slide itself. The joint connects two links, input link and an output link. Links are rigid components of the robot manipulator. Yes, these links are rigid components. The purpose of the joint is to provide controlled relative movement between the input link and the output link. Yes, this joint will provide the relative movement between that input link and the output link. Most robots are mounted on stationary base on the floor. Yes, all the robots are mounted on the stationary base on floor. So we will see a simple diagram for that. You can see there we have that this is the floor and this is the base for this robot, and you can see there this is the link 0 and this is link 1. These two links are connected by joint 1. So maybe this, yes, we will discuss later. Yes, this is a link 1 and this is link 2. These two links are connected by this joint 2. Let us see now. Let us refer to this base and its connection to the first joint as link 0. Means this is the base and this is another one. This is another part in that robot, and we will refer this as link 0. It is the input link to the joint 1. Yes, this is you can see that this is a joint 1. This joint 1 connects link 0 and link 1, right? So then this link 0 will be the input link to this joint 1. The first in a series of the joint used in construction of the robot. The output link of the joint 1 is link 1. Yes, output of this joint 1 is this link 1. Similarly, if you consider this thing, for this joint 2, link 1 is the input link and link 2 is the output of this joint 2. That is what they have been telling here. Link 1 is the input link to the joint 2, whose output is link 2, and so forth. This joint link numbering scheme is illustrated in the above. Yes, here this joint and link number will be given like this. Link 0, link 1, and will be joined by joint 1. Link 1 and link 2, and it is joint 2. And it's the end of the arm. So this is how that links will be joined with the help of this joint. And next we will go for this types of joint. Anyhow, this is not there for your syllabus. I will simply brush up that what are the different types of joint. Then we will go for the main classification of robots. So types of joints are linear joint, orthogonal joint, rotational joint, twisting joint, and revolving joint. So these two, that is your first linear joint and orthogonal joint, will provide that linear movement, whereas these three joints, rotational joint, twisting joint, and revolving joint, will be used to provide rotational movement there. We will see first one by one. Linear joint here. So this is will be the input link, and this is in the other color will be the output link. So whereas this is the input link. Yes, this is the output link actually, and here it can move on this input link. So you can drag this input link towards left, and even you can move this input link towards the right side. So here you can see here the relative movement between the input link and output link is translational sliding motion with the axis of these two links are parallel. So these two axes of these two links are parallel, and it will provide a translational sliding motion. Next we have this orthogonal joint, you can see there. So this is the input link and this is the output link here, and in the joint motion, yes, this is also translational sliding motion, but the input and output links are perpendicular. This is the axis of input link and this is the axis of output link, and these two links are axis of these two links are perpendicular to one another. And almost, whereas this thing that is both this linear joint, that is type L joint, and type O joint will give a translational sliding motion. Next one is rotational joint, you can see that. So if you rotate, if you make this input link to come downward, definitely the output link will go upward. You can see there joint motion in the rotational, that it will give a rotational motion. Next we have this twisting joint. This joint always involves rotary motion, but the axis of the rotation is parallel to the axis of the two links. Here if you twist this input link, then definitely output link will also get twisted in the other direction. So that is but here that will cause the rotational movement of this joint. And the last one is revolving joint. You can see again this joint will revolve, but here this output link, you can see there, this output link will spins about the input link. So this is the input link, and if you rotate this, if you give rotational motion here, this output link will swings, or you can say it as spins about this input link. So this is regarding all the joints. Remember that. So starting from the first one, that is a linear joint and its orthogonal joint will give the translational sliding motion, whereas this rotational joint and twisting joint and also revolving joint will give the rotary motion. Here we have clearly all these joints here, you can see that. Yes, we have translational motion will be given by these two joints, linear joint and orthogonal type of joint, whereas rotary motion will be given by using these three joints, that is rotational joint, twisting joint and revolving joint type. So these are just basics for you people. Next let us move to that classification of robot. Yes, industrial robots are designed to have various arm manipulators so as to have that motion in different directions. The possible types of arm movement that a robot is designed with defines configurations. A robot can have any number of following configuration. Yes, this robot based on that motion of its hand, or you can say it as motion of its arm in different directions, that robotic configuration will be classified as Cartesian configuration, cylindrical configuration, polar configuration, jointed arm configuration, and finally the last one is selective compliance assembly robot arm, that is SCARA. This is selective compliance assembly robot arm. Out of these five, we'll discuss all these first four here. 1, 2, 3, 4. Cartesian configuration, cylindrical configuration, polar configuration, and jointed arm configuration. So we can see the diagram for all these we have here. This is the first one, that is Cartesian coordinates. In this case there is no rotational movement, whereas only linear movement you can see here. A translational sliding motion you can see in case of Cartesian coordinates. This is cylindrical coordinates, and this is a polar coordinate, jointed arm, and this is the last one, that is SCARA. We will discuss these four. 1, 2, 3, 4. We'll go one by one. So first one is Cartesian configuration. Cartesian configuration robot is so called because arm movement of the robot is designed to move parallel to x, y, z axis of the Cartesian coordinate system as shown in the figure. So you all know that Cartesian coordinates x, y, z, and here these arm movement will be parallel to that Cartesian coordinates x, y, z direction. You can see that this is the exact x direction we have mentioned here, and this is the y direction, and this is z direction. So it can slide in this direction, that is parallel to this x direction. This link can slide in this as well as in this direction, and this link can slide in this as well as in this direction, and this entire setup, these two, that is this link and this link, can be raised and can be lowered about this link. You can see here with the help of this joint, this entire arrangement can be raised and it can be lowered with the help of this joint and this link. So it is in z direction. This is x direction, this is y direction, and this z direction. arm movement in case of this Cartesian coordinate will be parallel to x, y and z axis of Cartesian coordinates. So we will see here. A robot designed with this type of configuration capable of moving its arm to any point linearly within the rectangular workspace. So I will show you what is that rectangular workspace in case of rectangular workplace, or you can call it as rectangular work volume in case of Cartesian coordinate. I will show you that I have a diagram for that. Since the arm movement is linear, robot is also called as rectilinear robot or gantry robot. This Cartesian coordinate robot is also called as rectilinear robot or gantry robot. Yes, we have that some of the advantages of this robot: simple control due to linear movement and also easy visualize. That control of this robot is very simple because only linear movement will be there, no rotational movement, and also easy to visualize how that arm is moving. You can easily visualize that. High degree of mechanical rigidity, accuracy and repeatability. Yes, mechanical rigidity is high, accuracy is good and repeatability is also good. It is possible to carry heavy loads. It can carry that heavy loads. Movement can start and stop simultaneously along all three axes. That is, movement of the arm, it can start and stop simultaneously along the three axes. Some of the disadvantages: the arm movement is limited to small rectangular work volume. Yes, that work volume or workspace will be limited to only that small rectangular work volume. Occupy large space. It occupies that this Cartesian configuration robot occupies large space, but even if it occupies large space, but workspace will be limited. Our workspace will be very small there. Low ratio of robot size to operate volume. Yes, this is what size of that robot will be high, whereas operating volume will be very less. So thereby which it is low ratio of robot size to operate volume. Means it can reach only the smaller distance. So that is, I will show you with the help of diagram. Applications: it can be used in assembly work, welding work, machine loading and unloading work, surface finishing work and inspection work. These are certain applications of this Cartesian coordinate robots. You can see here. So that's what I said. Work volume will be, yes, this Cartesian coordinate robot can work along this rectangular volume. So you can see there. It represents the work volume of this Cartesian coordinate robot represents this rectangular volume here, or even you can see there. So this arm can move up to this point and it can move up to this point. Similarly, it can come up to this point and it can come up to this point. Similarly, it can move up to this point. Even in the bottom direction, here it can move up to the point, and here it can move up to this point. Here it can move up to this point. You join all the points. It will give the rectangular work volume. Even it has been shown here. This is Cartesian configuration. Work volume will be in the form of rectangle. So that's why they told that it has some rectangular work volume, and even the work volume will be very small. And next, let us move to this cylindrical configuration robot. So this cylindrical configuration combines both vertical and horizontal linear movements with rotary movement in the horizontal plane about the vertical axis. So here this cylindrical configuration robot has both that linear movement as well as rotational movement. You can see here you can see they have given the diagram here very clearly. So this arm can move in a linear way. It is in this direction. Similarly, this entire setup with the help of this joint can move up and down, that is linearly again in this with the help on this link. Whereas here they have given one rotational joint here. Yes, one joint which is used to give that rotational movement. Yes, you can see that is rotational. So with the help of which it can rotate in the horizontal direction. That is what they have been telling here. Configuration combines both vertical, this is z axis, that is vertical, and horizontal x axis linear movement. This is x axis, horizontal x axis, that is this is also linear movement, and this is also linear movement again, with a rotary movement in the horizontal plane about y axis. Yes, on this you can see there, and you can rotate this on this vertical axis, that is y axis. It is also called so because its motion sweep out a partially cylindrical working volume. Yes, it's this workspace, or you can say it as its motion of this arm can sweep out a partially cylindrical working volume. So that's why it has been called as cylindrical configuration robot. So you can see that is work envelope or profile of generated volume. Yes, if you make that link to move in that linear direction, that is in the x-axis as well as in the z-axis, and then on y-axis it has some rotational movement. So if you make that robot to move all the corners, or if you make that robot to move linearly along x and z and to move a rotational way in the y direction, then it will creates or it will sweep some partially cylindrical shape, and you can say that has been shown with the dotted lines. This tip of this arm can move to all these positions that has been shown with the dotted lines. So it represents a cylindrical shape. So that's why the name has been given as cylindrical configuration robot. This robot configuration finds application in radial workplace layout, where the work approached primarily in the horizontal plane and where no obstruction are present. So this will be used in case of this robot. Cylindrical configuration robot will be used in radial workplaces layout. So we need even where that rotational movement is also required along with the linear movement. So we will make use of this cylindrical configuration robot. You can see that work again, where is this is a cylindrical configuration robot. You can see this linear movement in x and linear movement in the z direction, whereas this linear rotational movement in y direction can be given. So that's why it is cylindrical coordination robot. 2 linear movements and 1 rotational movement. Next we have this polar configuration, or we can call it as spherical configuration robot. Geometry of the spherical or polar configuration combines rotational movement in both horizontal and vertical planes with single linear movement of the arm. So in the first Cartesian coordinates, all 3 linear movements in x, y, z direction. Whereas in case of this previous one, that is cylindrical coordinates, 2 linear movements, 1 rotational movement. Fine. Linear movements in x and z direction, rotational in y direction in case of cylindrical coordinate. Whereas here in case of this spherical or polar configuration, we will be having 2 rotary motion and 1 linear motion of the arm can be seen here. This configuration occupies and sweeps out relatively large volume, and access of the arm within this total volume is restricted. So it can occupy, or you can say it as, it can sweeps out relatively large volume, but access of this arm within this total volume is restricted. These robots rotate about the vertical axis. You can see there, this is a vertical axis. It can rotate, so there will be a rotational joint here. You can see they have given clearly shown this direction of rotation or movement. They have shown with this arrow. It's a rotational movement. It can rotate on vertical axis with the help of T joint of its waist on its base. So with the help of this waist on its base, it can rotate, that is by making use of the T joint, it can rotate on its vertical axis. Second axis is horizontal rotary joint, that is R joint. So you can see that this is the R joint. It can rotate about this horizontal axis here. This is the R joint with the help of which it can rotate in horizontal direction there. The second is horizontal rotary joint. Rotary joint allowed arm to rotate in the vertical plane. Yes, it can rotate in the vertical plane with the help of this joint. It can be lowered, it can be bent down, and it can be raised. With this entire setup, with the help of this joint, can be bent down and it can be raised. You can see this movement, the movement of this entire arm. With we can see they have clearly shown here. And making use of both axes, the arm can sweep through a partial sphere of radii depending on the length of the prismatic joint L shown in the figure. Yes, this is one which will move in the linear direction, whereas these two, it can rotate about this vertical axis again, as well as this entire thing can rotate about this vertical axis too. Along with this, with the radial or linear movement of this link, what it will sweeps is, it will sweeps out a partial sphere of radii depending on length of this prismatic L joint. So this is main thing. So based on length of this link, it can that radii of that sphere will vary. That means it will sweeps out, the work volume of this will be same. This joint, that is this type of configuration, will be similar to that of sphere. First one, Cartesian coordinate, work volume will be similar to that of rectangular rectangle, and in cylindrical coordinate system work volume will be similar to that of cylindrical shape, whereas in case of polar configuration or spherical configuration work volume will be similar to that of sphere, whereas this radius of this sphere will vary based on this, that is length of this prismatic joint L, or based on length of this link, radius of this sphere over the work volume, spherical work volume will vary. If the length of this link is very small, then radius of this spherical work volume will also be less. If the length of this link is high, then the radius of work volume will also increases. This is regarding polar configuration or spherical configuration. Next we have that last one, that is jointed arm configuration. This jointed arm configuration is similar to that of human hand. We can start from this. You can see that this is a base, and you can see this is a shoulder. It will be similar to the shoulder of human, and we have that upper arm, and you can see that the next thing is upper arm. Yes, next after that we have elbow. Similarly, that is human arm have that elbow, and next forearm. This is the forearm, and it will be the wrist again, and next thing is palm. So this is the one other joint, that is wrist, and this is elbow, this is shoulder. These are the joints, and we have this thing that is upper arm and this forearm will be treated as links again. Again this forearm and this palm which will be connected to this wrist will be called as links, and those two, that is forearm and the palm, will be connected by this another joint, that is wrist. This jointed arm configuration will be similar to, you can write this explanation for this will be very simple. Write this diagram, then this jointed arm configuration will be similar to that of human arm. Start from the shoulder, and this upper arm and this forearm will be connected with the help of elbow, and then again a forearm and the palm will be connected with the help of wrist. So it can rotate again, and we can see the combination of all these rotational movement here. So it can rotate about this joint, that is shoulder. Similarly with it can rotate on its vertical axis as well, and this is the elbow and this forearm. You can see that this forearm can rotate on this joint. Similarly this palm can be rotated on this joint, that is wrist actually. So we can see that many number of rotational movement in this case of jointed arm robotic configuration. So that is how this thing will perform the task. We can see 4 rotational movement in case of this jointed arm robotic configuration. Next we have certain advantages and disadvantages of robots as well as some applications. Advantages of robots: robotics and automation can in many situations increase the productivity, safety, efficiency, quality and consistency of the product. This is the main important thing, you all know that. Say production can be increased, safety, efficiency, quality can be increased, and consistency of the product can also be increased. Robot can work in hazardous environment. We told this thing already. Robots need no environmental comfort. So almost similar to one another, these 2 points. Robot work continuously without any humanity needs and illness. So definitely you all know that there is no illness for that robots. So it can work continuously. Robots have repeatable precision at all the times. That is, it can work precisely at all the times. Even if you perform that work for many days or many months, it can perform precisely. And robots can be much more accurate than humans. They may have milli or micro inch accuracy. Yes, accuracy of the robot will be definitely high when compared to human beings. Robots and their sensors can have capabilities beyond that of humans. Even if some of the sensors that will be made using the robots, they have capabilities beyond the capacities of human beings. A robot can process multiple tasks simultaneously, but human can do only one task. This robot can perform multiple tasks, whereas human can perform single task at a time. Robot replace human workers who can create economic problem. Yes, economic problem can be solved by making use of robots in working condition instead of laborers or human employees. Disadvantages of robot: robot lack capability to respond in emergencies. This can cause inappropriate and wrong response. In some emergencies, robot is lacking capability to respond in emergencies. It will cause inappropriate and wrong response. A lack of decision making power. In the first slide we just discussed it can make decisions, but there will be again still lack of decision making power for this robot. and that will make the decision based on what the programming will give. Sometimes that decision will not be sufficient enough to perform the required task there. So that is lack of decision making power. And loss of power, you need to supply the power for that robots, and that is loss of power. And when mean that will be this will be happen when it is having when it doesn't respond to the input commands. So then damage to the robot and other devices. In some emergencies, if it doesn't respond to that input command, then definitely the entire robot will get damaged. And we have that robots have limited capabilities in degrees of freedom. This is also disadvantage. Degrees of freedom is that is movement. In some cases it can move linearly, and in some cases it can move in the rotational direction. That is some limited capabilities. Like again, even we need to make some sensors for each different input commands. We need to make use of different sensors there, and vision system of that robot is also less there, and real time response of this robot is very less. And robots are costly due to initial cost of the equipment. Definitely initial cost of the equipment is very high, and installation cost is also high. Need for certain peripherals, and even you need to train that robot, and need for programming. As we said, one task is done, then we need to assign that robot for next task. We need to do the reprogramming. That programming and all is it is everything. These are the terms related to economic. Once you install that robot, definitely we can go on recovering that money, but still it is of initial cost is very high, installation cost is also very high. Then robotic application. So that robotic applications need to replace the human labor by robot. Yes, we can replace that human labor by robot. Work environment can be hazardous for human beings. That work environment which is hazardous for human beings, a robot can work efficiently. And repetitive tasks can be done by robots with accuracy and precision. Boring and unpleasant work. Some of the boring work for humans, where they will some work where the human beings or human labor will feel boring and unpleasant. We can replace the human labors by robots in that condition. And multi-shift operations. So you all might have heard about that operation, that is human labors work in the different shifts. Maybe the first shift some 8 hours, and second shift with the next 8 hours, like that. But robots can continuously work without any shift and all. Operating for long hours without rest. That is what it can operate throughout the day without rest. And this robot can be used in the assembly applications also, and even that is material handling application. That is pick and place, picking that material from one place and placing that same material in the other place. And processing operation, certain processing operation, and even you can use for inspection applications, like in the sense whether the product produced is of very good quality. It can inspect that thing also. That is, that robot can check the quality of the product and accuracy of the product, and also it can check whether it is durable or not. All those inspection, like even it can check the dimensions also. All those can be done with the help of robot, that is inspection applications. So these are all certain advantages, disadvantages of this robots. Along with that, many different robotic configuration we have discussed. What you need to study is you just study the basic definition of robots and certain characteristics of the robot, and then you just directly study that robotic configuration. That giants and all, they are not there for your syllabus. That is just basic introduction before coming for that different configuration of robot. All these four configurations are very important, and what you need to do is practice the diagrams. The diagrams of that robotic configuration are not so easy to write, so please practice all those diagrams of that robotic configuration properly. Okay, yes, that is enough for today's class.